Hey, hello, and welcome to the show. It is me, John Park, and it is time for John Park's Workshop. Here we are. This is the workshop, and this is where things are made and hopefully explained, or at least shown off to good effect, to maybe elicit questions or inspiration in you, the viewers and members of the community. And when I say you, I'm talking about the good folks in our YouTube chat and in our Discord chat. I know if you are somewhere else like Facebook, it may seem lonely. Where's all the chat? Check out our Discord. It's at adafruit.it/Discord. And you can look for that live broadcast chat channel. We've got DJ Devin 3 there, AT Makers Bill. We got Mike P, Jim Hendrickson, Some Nicey, Grover, Andy Calloway, Paul Cutler, Liz, Blitz City DIY. Okay, you're on. Nice to see you, Steve. We already have a question there. A question from AT Makers Bill. Not a question so much as a statement. Great to be revisiting all of the Xbox accessibility controller work we did. I should have brought mine. I have it inside the house. If you all are familiar with AT Maker Bill, he does accessibility technology, and we had done some work, gosh, it seems like a couple years ago now, on making your own controllers for this thing right here. Let's see, should just be able to search XAC. So I did a guide called DIY Adaptive Game Controllers. And if you take a look at this project, most of the, if not all of the things we did were to plug into these back here. This is, if you're not familiar with it, a large controller that can be used like a very large D-pad. At least the buttons are large. The D-pad itself is mostly normal size. This works with Xbox, works with, I think, direct input and X input, so a lot of older legacy systems you could use this with, Windows of course. And this has the mostly mono jacks in the back so that you can take buttons, arcade style buttons, contact switches, read switches, gesture controllers, what have you, that can essentially close or open a switch, and plug them into these mono 3.5mm jacks. There's also some provision for analog on a few of these. I think right trigger, left button, left button, if I am not mistaken. I think the thumb buttons are also potentiometer controlled. But this also now, thanks to this Trinky that Lamore has put out, TRRS Trinky, we now have the ability to plug in controllers, I guess up to 3 of them, because this is a tip ring sleeve controller. So with a splitter, you can get 3 buttons or switches in. And it's a programmable M0, Cortex M0 at SAMD21. So it's got a USB A plug. You can plug it right into a computer and do accessibility things. So Bill showed some footage last night on Show and Tell. You should go back and check out of a classroom of kids having a lot of fun playing games with different accessibility controllers that work well for them or customized for them. We may revisit some of that work we've done now that we have this thing available for $9.95, which is, I think, order of magnitude cheaper than sort of commercially available accessibility types of controllers from what Bill has said. Also, over in our chat, Toddbot showed this wild-looking thing. I found this in my feed earlier. Oh, Somenice shared it. Yeah, I misattributed that. Sorry. I had shared this with Toddbot when I saw it. This is pretty interesting. This is, let's see, do you have a link for it? Because I can't remember its name, but that image I'm showing there, this is a reconfigurable sort of little rounded cubey sphere things that can plug into each other in different physical orientations and configurations. And you can attach to each of the cubes different controllers, thumbsticks, buttons, D-pads, those types of things. So that's an interesting looking one. That's, I think, I don't know if it was recently available, but it recently came to my feed. So some interesting stuff in the world of accessibility there. And actually, I'd be interested to talk with Bill, or if you can share some insights, or if anyone else has insights into this, the fairly recently released PlayStation accessibility controller and ecosystem. I haven't looked closely at that. I haven't gotten one, but I'm curious what the feelings are about that, what sorts of input schemes it has. If you're wondering what I'm talking about, let me pull that up. PlayStation accessibility. Project Leonardo, it's called. And there's just a blog post about it. This is an interesting looking thing. I believe it can be added to change out the different button inputs on this, but I don't know how configurable it is compared to the Xbox one. Bill says, yes, the PS5 one is similar to the XAC in goals and approach. And they didn't match the wiring. Oh, no. Boo. Why not? Oh, my gosh. Come on. Do better than that, companies. All right. So those are just some things that are going on in the worlds of our chats. Hi, Dave Odessa, who's over in our YouTube chat. So thanks for stopping by there. I don't know if you're also in our Discord, but say hi to Dave over there if you join into the YouTube chat. So what do we got going on today? I have a coupon code for you so that if you want to go get some stuff, some neat things, including that little accessibility controller I mentioned there, you can get a 10% off discount today by using this coupon code, Conveyor. We'll be building a conveyor belt today, or working with a little conveyor belt for the track sequencer. So that's the coupon code, and that will get you 10% off in the store on any of the physical things that you can buy that we can ship you. So it doesn't work on software or gift certificates or subscriptions, but it does work on all of the good stuff that you can get in our store. So please go check out the new products page. That's a good place to get started if you're wondering what kind of stuff there is. There's this What's New link up at the top. Lady Ada showed off on Ask an Engineer last night. We've got some little press fit pin headers. If you want to use brute force and not a soldering iron, you can squeeze or hammer your way to adding pin headers to your projects. I've only tried these kinds of things once on a Raspberry Pi Zero. I believe Pi Moroni or Raspberry Pi Foundation, someone put out a double row 40 pin version of this kind of thing here that you put into the let me see if I can open an image in a new tab and zoom in on that. If you can see here, the pins have a little sort of wishbone moment there, and that gets squozed when you apply pressure to the pin So it gives you a mechanical and an electrical connection. So if you have absolutely got to not solder something, you can use, here we got some plier type of tools being used to squeeze that down in there, which will work probably pretty well. They were called hammer headers at one point because I think Pepperoni came up with a little jig that would allow you to tap them with a hammer without smashing, ideally, too much of the other stuff. The on-off key lock switch, that was debuted last night. That's a little turn your nuclear remote detonation switch kind of switch, not for use in super high security situations, actually. It's a pretty simple little lock with the same key on all of them. So if you buy one from Adafruit, you can unlock any of the others that have been bought from Adafruit. And it's a little, like, probably 4-disc wafer tumbler lock, so you can pick it with ease. So not a security thing, but kind of a neat switch, an electrical switch that is a keyed switch. We got some new thin solder, leaded thin solder. We have that TRS Trinky. There's a tripler Pi cowbell for tripling up your projects, which I'm going to get some of because I love that kind of format. Here was something I had done recently with DVI Pi cowbell and a doubler, but a tripler is really nice. And one of the features of the tripler is it's got a battery input, a stemma QT port, an on-off switch, I believe, reset button, and then all of the silk screens and other nice features of these that make it a little easier to work with Pi projects, rather with Pi Pico projects. So anyway, those are some of the things that are new in the store, but check that out. If you have stuff you want to get, throw it in the cart, and then just use this coupon code, conveyor, which Andy Calloway says, I have just conveyed the coupon code upon you. Also in the chat, I'm always amused by these. This is a TRRRRS switch, or a plug, which is available from DigiKey, apparently. I made a mock, like a joke Photoshop one a few years ago that had like 9 or 13 conductors on them, because, hey, why not? The possibilities are limitless, really. All right, there's your coupon code. Next up, I have a show on Tuesdays. I'm laughing because Steve just made me laugh with trrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrrr, which is the product pick show. On Tuesdays, I have a show, which is the product pick a product from the store, sometimes a new one, sometimes an oldie but goodie, and show you how it works, give you a little bit of a demo and a big discount. This week it was 50% off on this lovely infrared receiver. Here's a little 1-minute excerpt. IR receiver stemma breakout board. So what's happening is when I press, let's say, the volume up button, you can see my IR receiver back here is receiving that signal, and then it's telling my display to show a different piece of text. You can see the little 2 receivers there, horizontal and vertical, and the little switch there for flipping between the 2. There's the backside with the little jumpers that you can cut. Here is the IR receiver, and it's plugged in with one of these double JST connector stemma cables. And then I'll bring my little IR remote in here. If I press up, down, left, right, you can see the little receiver LED blinks there when it receives a signal. It also has the power LED on there. It is the IR receiver stemma breakout board. And that's right. Yes, that's what it is. I think we may have sold out of those during the show, but we should be getting in another batch of those. Oh, no, we have, wait, no, do we? I'm getting tricked. Let me go back to the store page here. Where'd you go? Are you it? Remote receiver. Yes, we are in stock. I think Aaron FirePixie was going to do a project with these, and Lady Ada was able to put a new batch in just this morning so that Aaron could get a hold of them because they sold out yesterday during the show. So what are you using them for? Tell us about your projects. What are you infraredding with? I'd love to know. Unfortunately, I ran out of time due to wacky circumstances to set up a Parsec for you, CircuitPython Parsec for you today. So I will make it up to you with a really good one next week, but there's not going to be a CircuitPython Parsec today, sorry to say. But also let me know if you have topics you'd like to see. I think one suggestion I had was going in a little deeper on some of the infrared pulse stuff. And I love this one because it's got two lights on it, and this camera does not have the filter a lot of cameras do. So you can see exactly what's going on with your infrared LEDs on there. So I may go into Pulse.io and some of the infrared libraries. Speaking of which, Bill mentioned worth checking out Chris Young's IR Library 2, IRlib2, which is an Arduino library for managing IR codes. Chris uses a lot of infrared stuff for his custom adapted home and gizmos. So infrared is a big help for Chris, and so he created a really fully featured Arduino library for doing IR decoding. And there's a link, by the way, over in our Discord if you want to check it out with Chris doing a bit of a tour of some of his IR stuff. DJ Devon3 says, I'll be building a live on-air style notification system that can be turned on-off with an IR remote. Though I have hundreds of projects I've meant to make and are sitting in a box. Not enough time. Amen to that. Okay, so next thing I wanted to do was give you a little bit of an update on, and I don't even have it here, do I? Oh, yeah. The USB MIDI host project that I was showing last time. So there's a version of it where I've put a Feather quadrupler. I've got a ESP32S3 here, not the one with the screen because I couldn't use the upside down one. I don't have the regular one here. USB MIDI host shield, that's the one that uses the Max 3421E. And then this is one of our feather wings for, I meant feather wing with all of these things. So USB host feather wing. This is the MIDI feather wing, and I have that with the little 3.5 millimeter TRS MIDI in-out plugs on there. You can also put the big DIN5 MIDI ones. And so I was doing some testing. Last time I mentioned how we're, this tiny USB MIDI USB hosting stuff is really hot off the press, hasn't been tested a lot. In testing, we found that it was essentially blocking code while it was in its read state, which it kind of is currently always looking for the MIDI incoming signal, and we didn't have a way to sort of break in there and use other code unless we were doing a read. So Toddbot did a bunch of work with that. Now Scott and Jeff Epler are in on the fun, and looks like Thatch, who does the Tiny USB, has released some updated code that has brought the minimum timeout to about 100 milliseconds, which may be usable for some stuff, and we may see if it can go lower. So I was testing that stuff out after the last show, and it's not quite ready to move forward with. So I'll be coming back to that, coming back to being able to host USB MIDI stuff, do some massaging of it, filtering, sending the MIDI on out either to a USB or or to a serial classic MIDI. So that's where that project is at. But in the meantime, I've also started up a new project, and I've got it sitting right over there. I think I'll show it over there and talk about it. Let me turn a light on. Oops, crash. Let me turn on this light here. That should help a little. I'm going to focus that too. Okay, so this is a revisiting of the notion of a physical drum sequencer. It could be used for other things, but other note types of things, but I'm focusing this on drum sequencing. And as you can see, I've got this sort of conveyor belt here with little Lego minifigure heads on it. And I have a couple of our optical reflection sensors. So these, I'll show them right here. Are a easy to use stemma breakout. Take that away for a second. And on the end of it is a little teeny package, which is an infrared transmitter and an infrared receiver. And so it just sends out pulses and will trigger like a button, essentially, when it has an object within its threshold. The threshold is between about 4 millimeters and a millimeter, and you can tune that with this little trim potentiometer on it. So the nice thing about this is that it is, as you can see from this little GIF image here, it is a plug-and-play stemma QT, or rather stemma, 3-pin stemma, full-size 3-pin stemma device. So easy to set up. You don't have to wire up the resistor and sensor, make your own little proto board. I've done that sort of thing on a previous drum sequencer project. So this is looking at it kind of from a slightly different angle and a more plug-and-play angle, less custom. In fact, the project that I'm referring to was this spinning disc step sequencer. So this is actually, you can see right here in this image, using a very, very similar type of sensor. It's our mini reflective infrared optical sensors. But you can see I had to kind of build a little custom board for them in order to make this work. Also, you can see it was more of a hands-on fabrication project, making custom discs here, printing stuff out, cutting things, gluing them, making a little mount for a continuous rotation servo, and it was all running off of this Cricut here. So this new idea is to make it more approachable by essentially creating all of the moving parts and the mechanical structure using, you guessed it, Lego. Someone said my audio is a little low. Let me try to goose that up a little bit. I'll just check my level. Test, test. Oh yeah, why are you so low? Let me goose that even more. Let me know if that clips or has any problems, but I just gave it a bit of a goose there. So I'm using, as you can see here, 2 of these reflection sensors. They are both running to a feather board down there on the side that has a tripler, and I've got some header pins there that I can plug into. And so each of those little stemma cables, these are pre-made. These are the ones that have a DuPont pin on the end of them, so you can just plug them into socket header. So no soldering there. I just threw a little heat shrink over them to neaten the wiring up a tiny bit. But those plug in and give us power and ground to the little sensor board, and then a signal is read either high-low. That's what those white cables are. So I have 2 of them here, and essentially the way these work is when I'm gonna just give it a little power to the microcontroller, but I'm not going to power the motor yet so that I can hand turn it. And what you can see here is, if you watch this red LED right here, you see that red LED? That's going to fade off when I don't have a Lego head in front of the sensor, and then it fades back on. And same with the one down below. You can see that one maybe a little better, actually. So you see that little sensor there? That is tripping a high-low. It's a little deceptive because the LED fades up, but it has a threshold. So this is not an analog signal headed to the microcontroller. It's simply a binary digital on-off. Did we trip something or not? So when it reaches that threshold point, it's going to send a pulse. And we'll take a look at the code that's running this. But essentially, I've got a reconfigurable sequence there. So wherever we place the Lego heads, that's the pattern that's going to be read. Wherever there's a space, we're not going to trigger anything. So this is similar to a piano roll, if you've seen either an old-fashioned piano roll or how that term is used in modern digital audio workstation software like Ableton Live or GarageBand. There's just this concept of notes on a staff moving along for different tracks that are playing either different pitches or, in this case, different instruments. So I have a kick drum and a snare drum is what I'm triggering with those. Now we've got a stepper motor here, and you can see I'm using a feather wing. That's the motor feather wing, and so it can be used either to drive 4 motors or 2 steppers. So I've got just driving 1 stepper here, and it has a external power supply. So I've got get it out of the way there. I've got a 12-volt DC wall wart in there that can deliver like an amp, amp and a half, something like that. So that's turning this stepper motor here, and this is just coincidentally, I think this is a NEMA 14 size stepper motor. It just coincidentally fits the spacing of a couple of Lego Technic beams. So I'll show you how I put that together in a moment. But the idea of this is that we spin the motor, and wherever we place the notes, we get a drum to trigger. So we can lay down drum patterns. Now, the conveyor belt that I'm using, this is what I had on hand. These are neat little Lego tread links. These, I happened to not have a nice musical number of them, and I did shorten it at one point to 16, which is perfect. But it was a little short for how I had things arranged. So I went back to this 22, which is weird. So you can't really get a nice beat out of it. No Western musical system works in this 22-step thing very well, at least not to my ear. But I'm going to actually build these out so that I have 32 links. And you can see there's little peg holes in there that I can put the heads on, so we can have essentially 2 measures of 4 beats per measure, or 2 bars. So it'll be 32 steps in quarter notes. And you can see here, I did a little bit of sort of mild amount of color coordination on there. You can see these, this is 4, this actually is the first beat of the measures, this red one, so 1, 2, 3, 4, and then the next measure there. So I'm going to use some bit of color coding like that to make life a little easier. And I'll show you this up close in a minute, see how that's constructed. But my idea is I can use either 2 of these tracks and 4 sensors oriented the way they are, and that'll give me 4, basically a kick, a snare, a hi-hat, and some other percussion, or maybe a closed hat and an open hat. Or I can do 4. I bought enough, I think I ordered like 128 links, so I can do 4 sets of these, and that can be 8 instruments. I can add a whole bunch of other drum sounds. Or what I think would be really interesting is to allow for accent notes, which I've never done in these types of drum projects that I've built, but essentially having a higher velocity hit, like so that you can emphasize accents inside of a measure. I may use 8 sensors so that I'll have 4 drum tracks, so kick, snare, hi-hat, open and closed, but then use the 2 tracks to do accent or not. So I have 8 sensors going into it, and we've got enough. These are just digital inputs on the feather there, so it's happy to. I think we've got plenty of I/O to be able to do 8 sensors. So that is the basics of it. Let me head over there and I'll show you. Oops, let's do this. I'll show you a little better view of this and get it operating, and then I'll bring it over to the computer so I can actually plug it into a synthesizer software so you can hear it do something. So here it is. This is kind of the more fun view because you see all the heads there. Hopefully I don't break this. Yeah, it's close to focused. There we go. So you can see a little better from this view what the creepy row of Lego heads looks like. I don't know how well it should turn okay sideways, so I'll fire it up and then we'll risk tilting it sideways. I should have just brought this camera down, but so let me tilt this back like so for now. I'll come out just a little bit. I have it on a little bit of a EVA foam pad here just because it's noisy, and on my workbench here with the wood top and the rest of its metal, it resonates a lot. So let's wind this back a little bit. Okay, so I'm going to give this power now. So you can see here, if you try to turn off the light here for a second, you can see the little red LEDs a little better. So every time one of the Lego heads goes in front of this sensor, you'll see it's getting sensed by the reflection sensor, and the same down here. I'm going to turn this sideways here so you can see it, a little fun view of it there. Turn the lights back on. So that is one stepper motor, and I'll just use one motor, I think, for the multiple belts. We have a, turn this off. We have a little shaft, motor shaft to Lego Technic axle converter here, coupler here. So I'm using that, and then whatever length of axle you want there, that'll work pretty well. The stepper is pretty nicely controllable as far as speed. It's probably not going to be a perfect, accurate BPM. I'll see. I'll sort of test it out and see, but I don't think this would stay in sync all that nicely unless we do a feedback loop. But again, I'm in CircuitPython on this to make it easy for people to play with the code, so I don't know that we're going to get super crazy precise timing out of this sort of thing. And I think one of the interesting aspects of the code that we'll take a look at is that we're kind of doing two big, important, simultaneous things here, which is controlling this motor at a fairly precise speed and reading these inputs. And so this, I thought, was a really good case to use the async I/O library, which allows you to do asynchronous tasks, sort of like multitasking, sort of a pseudo multitasking, without blocking each other, because we have timing things in here that would essentially cause these to either never read or read at weird intervals and then maybe mess the motor speed up. So I actually have these sort of two concurrent tasks going by using CircuitPython's async I/O, which I think works pretty well. So let's take, this is, by the way, fairly prototype. This was just kind of what I had on hand without a ton of planning. I don't have a mount for this, although I think I may use one of the Ruiz brothers 3D files to do a printable Lego coupler for this so that it can plop onto a plate and then be grafted into the system here. But let's take a look at this in action. Again, I'll apologize for the beats because it's 22 steps, which is just weird, so we're not probably going to be able to dance to it too well. And once I set this down and show it to you, I'll answer Bill's question about how the sensors are affixed into Lego, because that's always the question with these kinds of things, is how are we making non-Lego things work with Lego things. So let's go to a down cam here. I'm going to goose the exposure up a good bit. And let me see if this is a funny camera to wrangle, so let me see. Okay, so if you can see here, I have one of these versions of a modified brick, sometimes called a snot brick for studs not on top. Let me go get this view over here. There we go. So this brick basically changes our stud orientation 90 degrees. So I have that plugged into a Technic beam that is part of kind of what holds the sprockets in place that are turning the belt. So I'll push those in there, and then I just used a stack up of plates and bricks to get the height to what I wanted, and then the final thing is a plate and a double stick adhesive pad. So it's these little U-glue pads, which, what do they call them? Dashes. But U, the letter U, G-L-U, U-glue dashes. We actually sell some small packs of these in the store, I think. You can get them at the craft store. But they are perfectly 1x1, or rather 2x2 Lego tile sized. You just peel those off and then peel off the other side of it, and you can affix things. So they are really nice and adhesive. Those aren't going anywhere, so I think that's a pretty decent way to attach those, and then I'm just plonking in. So again, you could do a 3D printed solution of some kind probably, but this sensor only has 2 mounting holes on it, and they kind of hover over, just to get the sensor close up to the Lego heads, they hover over the conveyor belt there, so it would be pretty difficult, I think, to 3D print something. In fact, I may even trim the leads here so they're not bumping, they don't have a chance of bumping into the belt. I think I've got them high enough off of there, but it's a fairly tight clearance. And if I turn this way, you can see, so here is, I'm going to put my finger there, I'm blocking all the light. There you can see a little air between there. That's how close the sensors are to those heads. We could pull it back a little bit and adjust the potentiometer to get it just right, but that's kind of part of the tuning process there. But yeah, what I really wanted to do was try to make this as easy to build as possible, so getting these sensors into Lego system with the double stick adhesive. And then if you look over here, you can see my stepper motor has threaded holes in it for mounting, and those I was able to use M3 nylon screws and just screw them directly into these 2 Technic beams. And with the right stacking of plates, you can get it to where it's the same height as the system, and so it can turn that conveyor pretty nicely. There's a little wobble to it, mostly because this shaft coupler that I have is not really meant for that shaft, so it's at a slight angle, and so you'll see the whole system flexing and moving a little bit, which isn't ideal, but there you go, that's how it is. There's a possibility you could use like a clever little universal joint kind of to fix the slight mismatch, but I don't think it's necessary or worth the time to do. So let's get this back in action here. Let me go to, how about that? Is that a good view? Sure, that's exactly what I had before, right? Let's go to a view like this. And I'm gonna plug in, again, just the feather to USB-C. So that does not power the motor driver feather wing at all, so there's no worries there that it's trying to run this, I think it's a 12-volt motor off of USB. It's not going to try to do that. But with that plugged in, Again, you can see I can freely turn the motor, and if you look right here, you'll see this LED where my finger is when that head goes by. So what I'll do is I'm going to launch Ableton, if I have it on here. Do I have you on here? I don't have it on here. What do I have that can play some drum sounds? Uh-oh. Oversight. Yeah, I was thinking of bringing in a little synth setup for this, and I didn't. Oh well, we'll just play notes then. It won't be drums. Maybe we can make it percussive. Check, check, test. Hopefully that recovers on all the streaming. I just experienced a crash when I launched the synthesizer that I want to demo this with. So I'll give this a moment to try to make sure that everything's working. The main thing I'm worried about is audio going haywire, but I think it didn't, so that's good. We're back on YouTube. Great, thanks. Says, is this YouTube? You've got a confusing username to talk to on air. Let me check here. Okay, Twitch is back too. Great, thank you. So yeah, I blew up my streaming software by launching some synth software. So let's see. I'm going to try to set my synth software to use, yeah, Toddbot mentioned to me on the side, I should get a separate synth box. I really was about to. I ran out of time. So let's see. I'm going to tell it to okay, I'm going to tell a piece of synth software to play over my speakers. You should hear this. That's fairly muted. Let me. All right, maybe we'll try that. It's got a lot of upper end. Okay, so my feather here should be acting as a USB MIDI device, and it is sending out. I won't show this to you, but I just opened up a MIDI monitor app to see. So it's sending out on-off messages for notes 46 and 47, but it's sending them on channel 10, and I was using that because that's a pretty typical drum MIDI channel. I suspect that my synth software here is expecting that to come on channel 1, maybe. So I'm just going to change the code here, which I've got to fix the view of after crashing. Sublime text. Okay, so I'm going to tell let's see, 99 is note on channel 1. What do I want? Oh gosh, I have this in hex. Let me just make the synth software work. Can I tell it to receive on channel 10 or not? Maybe this was a bad choice of synth software to use for this. Yeah, it's just not getting those messages. All right, wait, I'm going to quit that. I'm going to save my broadcast software, so if we crash, it's a little quicker to restart. And now I'm going to risk launching something else. Let's do... we'll try Vital. Don't crash. Okay. Good. Is it playing? All right, let's get it. Sorry, I know you can't see any of this, so I'm trying to narrate it a bit. Okay. You're not getting, oh, did it? Nope. Why are you not getting that? Yeah, unfortunately, the synth software I launched that didn't work is written by the same person who wrote this second one, so these are maybe not a good choice. All right, last ditch on this. I'm just going to try VCV rack. And you know what? I will show this while I go through it, so at least maybe there's something interesting to see. So let me add a capture of window VCV rack. Okay. Move that over there for you. Okay. So let's see, what do I have going on in here right now? Reading all channels, sure, I could even say channel 10. All right, let's try all channels. I don't know why it's not receiving MIDI. Something's strange here. Okay, yeah, maybe it's not these softwares and how I'm setting it. This was working on Ableton Live. It doesn't seem to be working on anything else right now. I'll set it spinning just so that I can try a couple software things without having a hand turn that. So let me grab my 12-volt power here. I swear it does things. Otherwise, you're probably thinking this is just an elaborate way to spin some Lego minifigure heads around. But it actually does play musical notes. Okay, so this should start spinning. And I see the LEDs lighting up there, so that means that it's triggering. This is core MIDI. That's the device. Why does it say it's on port 1? No, it's port 0. Okay. Yeah, Todd says Ableton is usually rock solid with MIDI, which is probably one reason why it was working. So I'm going to make a new, I'm going to clean this file out. Oh, I know why. Do I know why? I think I know why. No? Okay. Yeah, if this thing's not on, it doesn't work. All right, so let's do fresh scene, audio. It needs one audio device or it just won't run. Let's do MIDI. Should be MIDI to CV. There's the feather device. Let's start with that channel, and I'm just going to grab a scope so we can see if anything's coming in. Oh, wait a second, did I grab the wrong? Yeah, I grabbed CV to MIDI. I need MIDI to CV. Okay. Feather, all channels, yeah. Okay, it's getting it. And here's the gate. Okay, that's a good sign. So if you look at the note here, it's just sending two different MIDI notes that are actually right next to each other. So if we gain this up a bunch, where'd you go? And adjust the time. Oh wait, did it stop again? Oh wait, I turned off trigger. There we go. Okay, so those are the two different MIDI notes coming in. Those should be corresponding to the pattern of the heads, basically. If you watch that over time, it should look the same. So that means now I should be able to bring in, let's say, oh, I don't have that module, okay. What, I have no drum modules in here? Uh-oh. Okay, we'll just bring in a VCO and a VCA. Sure, that'll work. Okay, so every time a note comes in, what do I need? So the output from, let's do the square wave here. We should hear something there. Yeah, it's my iMac speakers. Huh. All right. I don't know why. Let's stop that spinning and see if the hand... No, something's wrong. Let's see. Channel 10, you're it, right? Scope from... Yeah, that's working. DJ-Demo3, yes, it is like a Lego Calliope, except you have to imagine the sounds right now, unfortunately, because I can't get an audio demo to work. I'm so sorry. But I think I'll bail on trying to get VCV Rack to show you. I will, however, pause this motor here and show you what's going on with the code for this. Where's that? Let's hide this. Okay. So, you're the code. Yeah, okay, so like I said before, I have kind of two things happening. One is the motor spinning, and the other is watching these two sensors. And then when I watch those two sensors, I'm setting out a MIDI note. The way that I'm doing those things at the same time is with async I/O. So the code here, things that are interesting, here's motor kit and Adafruit motor. Those are used so that I can pretty easily control the stepper. And then I'm using keypad as my sort of very easy to use button reading and debouncing and queuing setup. Love keypad, even though these aren't keys or buttons, they work in that really well. And then USB MIDI. Setting up the motor. This works even though, well, this is a Featherwing, works over I2C. So it's just eating up basically a pin on the Feather. And then I'm setting up these two sensors on, I can't remember why I picked 10 and 12, but there you go. I've got the two sensors plugged into pins 10 and 12. And these are, I'm setting them up with keypad as pull up, I think, resistors. So when they get pressed, they actually will say that they're false. They're going from high to low. MIDI setup here. I've got MIDI port and the two MIDI notes I'm using. I don't think I'm using that anymore. And then I have a function for playing a MIDI note, and this was the one where I confused myself because I used a byte array, which always confuses me. It's probably why I couldn't get it onto a channel 1 or working. And these write a MIDI note on and a MIDI note off. On note, whatever note number, and then a velocity of 120, and then off note number and a velocity of 0. And then here comes the async part. So I have two functions, things that I normally would have done just either in the main loop or as their own functions, and they are check sensors and run motor. And rather than make those a normal function, I've made those as async I/O functions. And then what happens in the check sensor function, it loops, so it has this while true. This is keypad stuff. I called it optical sensor, but it's events get. See if something has happened on either one of those digital inputs. If something happens on that pin and it is a pressed You can also do released if you want. We take that number, it's either 0 or 1, and I'm casting this variable track number just so I know, hey, which one did I press? I print something out, so you can see here in my REPL, it'll say tripped 0 when I have this upper sensor, boop, and then it'll say tripped 1 when I have the lower one. So if you see my little readout there, those are changing as we pass the little heads in front of us. And then I have a play drum function getting called. This one gets called with whichever MIDI note from this list corresponds to the track number. So track 0 is 46 and track 1 is 47. And then we do this await async IO. Even though this one's not pausing, we still need this await async IO. This tripped me up when I was setting this up. I need this so that async IO can run these two separate functions. So you do need this await in each of your async IO functions. The second one here is run motor, again, while true, so it constantly loops. And all I'm doing on this one is I'm calling the motor kit stepper 1 one step, and then I've told it to be going backwards in this case, just how things were set up. That's the direction I want it running. We could flip that by either leaving this out or say forward. And then the style is a stepper double, which excites the coils in a way that gives you a nice smooth motion. You can also do single and I think some other versions of how it excites the coils inside of that stepper to sort of pass the bucket around. And then this one, I'm using the async IO sleep rather than a time.sleep. Again, we do the await, but in this case, I have a very particular timing in here, and that's how fast the thing is going. So if we wanted to slow this way down, so let me plug the power back in. I'm going to resave that. It's going to go 10 times slower. So that is how we'll control roughly the beats per minute. And we can get pretty fast with this. So I haven't done any of the math to figure out what the sort of range, the full range on BPM is, but if we can get somewhere around 140, that would be great. So let me close that. Unplug this. And then when we have a couple of these functions that we want to call with async IO, we create this main function, async, again, async define the main function, which creates tasks of those functions you want to be calling. So we set up one called motor task. Motor task is create this run motor task up here, sorry, this one. And sensor task is create this one right here. And now those are essentially available to be used by async IO. So it knows that it can run those things. And then this await async IO gather uses those awaits that I had there and the two created tasks that I have to say those are essentially the two that we're pinging back and forth between super quickly. If my understanding of it may be completely wrong, but that's kind of how I think of it, is that they're not really both happening at the same time, but they are swapping back and forth between those tasks so fast that it might as well be. I hope Dan's not listening because I'm sure that was totally wrong. But and then the final thing is this is what runs it. You'll notice there's not your typical while true loop. It's just saying async IO run main, and it's this one right here. So it's just going to run that. It's just going to go basically run those two tasks at the same time. This can get more complicated if we need to pass data between the async IO tasks, and I'm not having to do that here. I may explore that a bit. But that gives us the ability to run a motor and check those sensors. And I promise you also send out MIDI notes, which it is sending them, but for some reason I can't seem to convince any synth software in here to do something with it. So I'll set that up as a better demo for next week. But it was a lot. I spent a lot of my time actually just getting this thing working as well as it is. So I'm really pleased with the fact that we can now read those. You can see here getting our little tripped task printouts done and be able to swap out the heads. What I came up with for these swappable parts is these light bluish gray half pegs with no split in them, they're a bunch of different Technic pegs. These are great because they have a lot of friction going into the track there, but they're not so much that you can't pop a head on and off pretty easily. So that should make it, if it's at a slower speed or you just pause, I'm going to add some more UI buttons to adjust speed and to just pause for a moment and play. You'll be able to swap your pattern around just by pulling the heads off there, and the pegs shouldn't come out because these are in there really nicely. Some of the other colors, these gray ones, they have a split, so they pop out a little easier. So I'm just using, I ordered 128 of these things here. I maybe should have gotten 256 of them so that I could do 4 of these tracks with the main beat and the accent, but I think I only have half of that. So may need to get more. They're very cheap, by the way. I used Bricklink to order these. Hopefully they'll be here in a week or so. DK says, hey, just joined. Are you sharing your code somewhere? I will be. This will be a Learn Guide, and I will share it once I get it up and running in a good enough state, and it's been pi-linted to make sure that I'm not making any errors in the code that'll mess people up. So this will be in an Adafruit Learn Guide. You can go to learn.adafruit.com to see, if you're not familiar with it, what that looks like, what the projects look like. But we use a GitHub repo called Learn Guides, Adafruit Learn Guides, or Adafruit Learn Guide System. In that repo are all of the code examples from our projects that have Learn Guides. So that's where that'll be. Let me open up the Discord, see if there's other questions. Somebody said, did you see the Lego Retro Radio coming soon? You can put your phone in it. Yeah, that thing is pretty cool looking. Love the color. Todd, no. Todd says add a color sensor so you can specify accent or not. No, I don't want to deal with color sensors in Legos again. Not now. But maybe the 2 tracks. Maybe that's the way. Maybe this is the accent track down here, and just to make this thing as big as possible, use 8 different sensors on it. Mike P asks, what was the reason for the awaits to sleep? Isn't await usually used for waiting for something to complete? Yeah, I don't know why it's necessary in the case where I'm not sleeping. I think maybe that does just wait for this task to run through one time and complete. That's my possibly erroneous understanding of it, Mike. But if anyone else knows and can elaborate on that in the comments, that would be great. Let's see. What else? Thank you, DJ Devon3. Yeah, I've been looking for a good case to use async IO that really could illustrate it, and hopefully this will make it easier for people to use. I'll start to understand it better so I can maybe explain it in the guide in a way that will resonate with people who are doing these kinds of projects. ATMaker Bill had to run. We'll watch less later. Thanks for the show. I never got the synths working, Bill. Sorry. Yeah, Todd says, how about an existing VCV patch that you know generates audio? All right, I'll give it one more shot. Why not? Let's. We've got a little. We're just a little bit over. Let me get rid of that, and I'm just going to take this wave. Yep, that makes sound. Okay, that's a good sign. And if I bring in MIDI to CV, here is the question for the chat, because I don't think that's getting those signals. Yeah, and I don't have a lot installed on this. There's better MIDI monitors that can work inside here. My MIDI monitor on the system is showing these notes coming in. Question to the chat, and possibly you specifically, Todd. In this byte array, how do I send that to channel 1? Is it 09? No. Is it 90? and 8, 0. Will that go to channel 1? Let's see. Yes, okay, that's going to channel 1. So back to rack. Channel 1. Volts per octave going to volts per octave. Let's put that into the scope. Good. Maybe the gate. Maybe this is too fast. Is it too fast for this thing? This is maybe going to break everything about async I/O, but I'm going to put a little tiny sleep in my MIDI play. Hold on 1 second. If this works, I'll show you what it is. I don't think it's working. Gate. And nope. Don't know why. Something's busted. All right, I'll give up on that. This is what I was trying in the code, was just to put a little bit of a sleep between the message that writes on and off, but maybe it was just not getting it. But, any notes in the comment? Yeah, it sends that note off real quick, and maybe, just maybe I can tighten up the ADSR enough that. Ah, it's my attack. All right, who said that? C. Grover, you made me think, what about my ADSR? Okay, so I can crank that level a bit. Not the most exciting demo. I don't know if I have an easy way to get a drum in here right now. But you can see basically, if I change the note value, let's do so you can see low, high. So that bottom row there has the high pitch notes, and the top row has the Charles Burnford asks, what's the address of the brick source that you use? I use Bricklink, which is, I think it's bricklink.com. It is essentially eBay for Lego, and it is now owned by Lego. It didn't start out that way, but a few years ago they bought it. It is a bunch of separate sellers, so you find the one who has the stuff you want, who's near you, who can ship quickly at the price you want. Bricklink, that's what I use. So now you can see we can pause this for a second and rearrange some heads on here. Let's see if it'll capture the 3 in a row kind of thing. I'm going to move them all. Actually, let's move them to the bottom row. So this should be a bunch of the high beeps, and I'm going to make it faster. So I'm going to get rid of that time sleep I did too, because that might screw up our reads. Oh, you can't hear it too well just because, again, I think my ADSR envelope there is messing with that. There we go. Yes. So, Andy Callaway, this is the dream. And I'm so sorry I didn't have a good demo for this setup at the beginning. Compose music by swapping Lego heads. That's the goal. That's my dream. Should have opened with that. And you can see here, actually, the two that are close together, it's not picking those up. If I can find a tiny screwdriver, I can adjust that trimmer pot to where, if you look at the red LED right here, it is not really, it doesn't know that it stopped reading. It thinks that that was 1, because it just doesn't get, the reflectance doesn't get low enough between those two. I think I can tune the potentiometer to where that space between the two is a little darker. Let's see, there. So now, that should work. It's dicey, but let's see. Nope. That time it did. That time it did. That time it missed it. So it's not quite sure. It just may be going this fast, or maybe moving this away a little so that we're not getting as much reflection off of the one that's kind of leaving before the next one comes. It might be that using white, because Lego makes this piece without printing on it, it's all white. Those may be better, but they're nowhere near as fun, so I'm not willing to lose out on the yellow heads there. But anyway, that's where I've gotten with this. So I'm excited that. Thanks for all your help in me getting actual sound coming out of it to show you that the MIDI was actually being sent. And I got rid of the sleep here. Don't need that. It's just I was not opening my envelope fast enough to let any sound through before it was closing. So that was just me being silly. All right. I think that is it. That's what I've got. So I will remind you, this is the coupon code for today if you want to go get some cool stuff. Get yourself a stepper motor. Get a motor feather wing. That could be useful if you want to do this kind of project. These sensors are great. I think we've got them in stock still. These are the TCRT 1000 optical reflectance sensors, and they're basically plug and play, which is a lot of fun. So the other thing I wanted to show you in how I'm plugging that in is just this. You can see here on the feather tripler, this is, again, feather pinout on the sides, but there's a nice row of power and there's a nice row of ground, and so that'll really help with plugging a bunch of sensors in. You can see I've got, I think, 8 that I could do, so we can do 8 sensors and get power and ground right there from these. So that's a neat little convenience there, so you don't have to, again, do any soldering. You'll be able to just plug in these kinds of stemma wires, and off you go. So I think that's going to do it. Let me know if you have any other thoughts or questions, and I will... a question from Andy Stewart. Can I send a request to you? Is there an email or somewhere else? I don't really have availability for private requests. If you want to ask about something just on the open channels, that's great. I think you had asked something about doing video over the TRRS Trinky, which I don't think is possible on that M0 chip, or if it's possible, I don't think I've seen code for it. The little composite video projects have all been because of ESP32, so I don't think that that's going to happen. All right. C. Grover says, going to get more Lego now. Excellent. Andy Calloway taking off. Bye all. I'm way over time. Let's get out of here. Thanks, everyone. Have a great day, and stop by for, I believe Scott is doing a deep dive tomorrow. We'll be back on Tuesday with Product Pick of the Week, Wednesday with a 3D Hangouts. I'll be hosting Show and Tell. We'll have an Ask an Engineer and more. There'll probably be a Desk of Lady Ada thrown in there somewhere at an unpredictable hacker time. For I'm John Park. This has been John Park's Workshop. Bye-bye. Bing, 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 bing.